So, hello everyone, and I welcome you all to APJ Academy, where we are nurturing the young minds to become engineers, and not only normal engineers, the engineers from IIT. So, basically, we are here to make you IITians. तो स्टार्ट करते हैं हम अपने इस YouTube चैनल का। आज का हमारा सबसे इंपॉर्टेंट टॉपिक जो है वो है गॉस लॉ के न्यूमेरिकल्स आपके IIT JEE के एग्जाम में किस तरीके के रहेंगे। So basically in today's class we are going to study about the Gauss laws, numericals and the conceptual questions which might come in your exam. So India's best faculty for JEE and NEET is now on this YouTube channel. Or I'm happy to announce that APJ Academy is launching its full year course, in which not only you get all the recorded sessions, live sessions, but also you are getting personalized attention from very qualified personal mentors. And other than that, you will be getting complete PDF study material free of cost. Also, the major test series, minor test series, and multiple assignments and lessons with our course. And the course price very less. It's first time on YouTube when any academy providing you the quality content is providing you such an enormous discount. Now you can access our complete course at rupees 490 only. Basically the cost is 3990 and you can get it by paying only rupees 490. So enormous discount is currently going on. And myself Manoj Kumar, I'll be teaching you physics here on APJ Academy. So let me start our today's lecture. Basically in today's lecture we are mainly concerned about what is Gauss law and which types of questions might come in your exam. So there are two types of questions in physics which might come in your exam. First one is the conceptual question, right? If you know the concepts, then you can easily solve these questions, isn't it? So you must know that what are the concepts required to solve the Gauss law. The concept is very simple. What is the concept? The concept says that if you have to calculate the total flux, total electric flux to an enclosed surface, then what you need to do is you just need to know the enclosed charge, have to divide that flux. And other than that, as we know that the flux is also equals to dot ds as per the definition, right? So this is our Gauss law. Basically the surface which we are choosing, the Gaussian surface which we are choosing, surface also known as Gaussian, and at this surface, right, at this surface basically the electric field should be continuous. Electric field should be continuous, constant. The condition on Gaussian. So we can choose any Gaussian surface, we can choose any closed figure, whatever comes in your mind, you can choose that figure. But the important factor is at that Gaussian surface, the electric field must be continuous and must be constant at every point. This is first condition. And also the electric field on this Gaussian surface is due to all charges. The electric field which is coming here is due to all charges. Whatever charges are present there in the vicinity where we are finding the electric field, the all charges will contribute here. So this electric field is due to all charges. भाई वहां पर जितने भी हमारे पास चार्जेस मौजूद रहेंगे उन सभी की वजह से ये इलेक्ट्रिक फील्ड हमारे पास आ रही है. So this electric field is due to all charges. So I hope that this point is clear to you, that the Gaussian surface which we are choosing must have the electric field as continuous value and it should be a constant value. Other than that, the electric field which is coming here should be due to the all charges. And next thing, but the flux which we are putting here on the right hand side, the Q enclosed, it is only due to the only charges closed by Gaussian. Gaussian surface. Okay, so ये हमारा है concept. But अगर आपको बस यही चीज आती है ना, so you can easily solve the conceptual questions of Gauss laws. And इसके बाद तो भाई हमारी applications हैं, and we have already derived each and every questions related to the Gauss law, right? One derivation is pending that I will do today. So let's move forward with the questions related to Gauss law, and that too from your JEE previous year question. But first of all, we are having the first question here. I have to solve this question. Please let me know that what is the answer here. Please let me know that what is the answer here. Here the electric flux through the surface. You have to find out the electric flux through the surface, right? So there are three surfaces present here. So the surface 1 is this, surface 2, surface 3, surface 4. You have to find out that where the flux is maximum or the flux is least, or electric flux through the surface is same or not. Basically, electric flux through the surface do not depends upon the surface area, right? It do not depends upon the surface area, because क्या वहां पे कोई surface area आ रहा था क्या total flux के across? नहीं आ रहा था. So it do not depends upon the surface area. तो हमारे पास सारे के सारे surfaces पे same ही हमारे पास flux आएगा. So the answer to this question is same for all the charges, right? Let's move forward. Next question. Next question is also very important question. Here what is being asked in this question, 5 charges Q1, Q2, Q3, Q4 and Q5 are fixed at their position. So there are many charges here. S is the Gaussian surface. The Gauss law is given by, this is the Gauss law. This is the Gauss law, and you have to tell us that कौन सी statement इसमें से सही है. You have to identify that which one of the statement is correct. And please, whenever you find such types of question, please ensure that whether this question is asking you correct or incorrect statements, because lots of times students says it was my silly mistake. If you really want to become an IITian, it's not a silly mistake, it's a blunder mistake. It's a blunder mistake that can take you from IIT Bombay to IIT Delhi, to IIT Delhi to IIT Jammu, to IIT Jammu to NIT, from NIT private colleges, right? And from private colleges to somewhere which you do not even know. So tell me that what is the answer here? Basically, we know that the electric field is due to the all charges. So wherever I found that electric field is due to the all charges, I ensure that it might be the answer, right? So this one might be the answer. And we know that on the right hand side, the charge must be enclosed in the Gaussian surface. So this is our Gaussian surface. The charge enclosed here is Q2 and Q4 only. So on the right hand side, we must be having Q2 and Q4 only. So here we are seeing that Q2 and Q4 only. So option B is our answer, right? So option B is our answer. Shall we move? Let's come to the next question. This question is also very important. Basically what is there in the question आपको बता रहा है कि भैया आपने क्या करा है, various points पर you have kept multiple charges. So you have kept charges at the corner. When you placed any charge at the corner, the flux will be Q by 8 epsilon naught. I had already explained this in the previous section, right? I gave you one chart through which you can do it clearly. So the next part is B. B is the midpoint of an edge of the cube. So B is the midpoint of an edge of a cube. So whenever I am placing my charges at the edge, flux will be Q by 4 epsilon naught, right? Next, C is the center of the face of the cube. So whenever I am keeping my charge at the center of the face, the flux will be, and similarly, whenever I am placing my charges on the face, so here also at point D, D is the midpoint between B and C. So this is also a face. This is also a face. So both of these charges are face only. So phi will be equals to Q by 2 epsilon, because half charge will go inside, half charge will remain outside. You know that whenever you are finding the flux, only have to take the charge enclosed by the surface. So only half part is going inside. Are you getting it? When I am placing any charge on the face of a cube or cuboid, the only charge which will goes inside is half. See this part. I am having one tape here. Imagine that this is the face and this is my charge. If I am keeping my charge here, अगर मैं charge को यहाँ पे रख रहा हूँ and I am keeping that charge on the face, तो मेरे पास क्या रहेगा भाई? Half part ही तो जाएगा अंदर की तरफ. Only half part will go, right? So whenever I am keeping my charge, only half charge will go. So now we are moving forward. This is JEE previous year question, so you have to solve this question. Please start ho jao and solve this question. Solve this question. So let me start. First of all, what is given to us is the electric field. So electric field given here is 150 y square j cap. This is the electrical field which we are having, right? So it is going only in the y direction. What is this j is showing? This j is showing that electric field is going only in the y direction. This is going only in y direction, right? Next part, the side of the cube 0.5. So this side of the cube is 0.5 meter is placed in the field as shown in the figure. The charge inside the cube they are asking. So we know that there are 6 faces in the cube, right? There are 6 faces in the cube. And through these 6 faces, only 2 faces will be having some flux. No? One face will be having one face. Why not this face? Otherwise, in all 5 spaces, the flux is 0. How many of you are able to identify this? This is JEE main. Very easy question. Out of 6 faces what we are having in cube, only one face is there which is having flux not equals to 0, right? Because if I'll consider this face, the area vector will be having its direction outside, right? Area vector will be outside. But what? when area vector is outside, right? Area vector is outside, but the electric field direction is this side. So theta will be 90 degree, and when theta is 90 degree, we know that the flux is, we already know that the flux is E A cos theta. So when theta is 90 degree, we will be saying that the flux is 0. So only one surface is there which is contributing, and through that surface the flux will be, through that surface the flux will be EA, right? EA, and that will be cos 0 degree, because at this surface the theta is 0 degree. How many of you are able to, at this surface electric field is going also in this direction, theta will be 0 degree and cos 0 degree is 1. So we know that phi is equals to EA, and the electric field value at this phase will be equals to 150, y is 0.5 square. So I can write this as 150 0.5 square. So this is my electric field, and what will be my area? What will be my area? Area is square only. All the faces of a cube, is square only, right? So that will be 0.5 square. So sir, the flux will be 150.54. Yes, and as we know that the flux is equals to Q enclosed divided by epsilon naught. Is equal to epsilon. Okay, and you know the value of epsilon naught. The value of epsilon naught is 8.854 10 to the power of minus 2. You have to substitute this value to get your answer. Solve this and do let me know that what is the answer you are getting. Please solve this question and do let me know that what you are getting the answer. Solve this question. I'm having this scientific calculator with me. This type of calculator you will get once you get into the engineering. So this is 150 into 0.524. So it's 8.3 into 10 to the power minus 11. What we will. The answers are very close. Even if you will able to calculate the value, the answer here is minus 11 and minus 12. Just a minute error. You will get a gift from IIT JEE which is minus of 1. तो आपको बिल्कुल भी ब्लंडर मिस्टेक्स तो ये करनी नहीं है. Okay? Try to avoid these types of mistakes for exam. So here is next question. यहाँ पर आपको एक क्वेश्चन दे रखा है, and from the question you are getting that which statement is true for Gauss law. So here basically you are having 4 equations, 4 statements, and you have to identify that out of these which statement is correct. So the first statement is saying that all the charges, whether inside or outside the Gaussian surface, contribute to the electric flux. So it is wrong. Why wrong? Because only the charges which resides inside the Gaussian surface contributes to the electric, right? Next is saying that electric flux depends upon the geometry of the Gaussian surface. No, it do not depends upon the geometry. Right, we already saw that Gauss law is super se bhi upar. It do not depends upon any geometry. Hence, it will give same result for everything. Right. So we are having here that electric flux depends upon the geometry. So no, it's wrong. Do not depends upon the geometry. Third point is Gauss theorem can be applied to a non-uniform electric field, and the fourth point is the electric field over the Gaussian surface remains continuous and uniform at every point. So basically, what they are asking is which statement is true. So Gauss theorem can be applied to a non-uniform electric field. Basically, this non-uniform electric field should not be on the Gaussian surface. So something missing, something is missing here. Right? Next thing is electric field over the Gaussian surface remains continuous and uniform at every point. This is what I already told you, that this is the condition. This is the condition which we must, right? The condition which we must. Please इसको mark कर ले, यही आपका है correct answer. This is the correct answer which you are having. Next question is very important question, and this question is basically from NEET. This question is NEET previous year question, but these types of questions I hope that you might get in your JEE mains. So this question is, the charge Q is enclosed by a Gaussian spherical surface of radius r. Okay, so I am saying that, let's assume that I am having charge Q and I am having this charge Q. Radius is r. A charge Q is enclosed by a Gaussian spherical surface is there of radius r. If the radius is double, so they are saying that what if radius is doubled? Radius double कर दी तो क्या हो जाएगा? Radius double कर दी तो क्या हो जाएगा? What will happen if we will double the radius? What will happen to the electric flux? Will it remain same? Will it becomes more? We already know it. Sir, we already know that the Gaussian surface, that the flux through the Gaussian surface do not depends upon the geometry. So whether you increase it, whether you decrease it, the total flux will remain same. So it will remain same, right? It will remain same because we know that the total electric flux passing through a surface do not depends upon the geometry. So it does not matter whether the radius is doubled, tripled, okay, or whether it is halved. So it doesn't matter. Is everything fine? Now we forward, and before we proceed, I want to make some announcement that if you are really want to crack your JEE exam this time only, then please join our Telegram group, which is ALT JEE. Just you have to download the Telegram app, and once you download the Telegram app, just go to the search button, and there you can search our ALT JEE channel. The link is in the description as well. If you have already installed Telegram app in your phone, if you are attending this class from your phone, you can click it directly, right? So basically, when you join this Telegram channel, you will be getting free PDF study material, you will be getting free classes, announcements, counts and prizes. So many things are there which you are getting. Let's move. And please subscribe this YouTube channel. If you haven't subscribed this yet, please subscribe this YouTube channel, because on this YouTube channel you are getting amazing content from me as well as from India's topmost faculties of JEE, right? These faculties are having more than 10 years of experience teaching students like you. So we will be covering multiple books which is required for your JEE exam, and not only for your JEE mains but also for your JEE advanced. So शुरुआत करी है नीचे से, जाएंगे हम सबसे ऊपर, राइट? आपको परेशान बिल्कुल नहीं होना है, एंड यू प्लीज सपोर्ट अस so that we can give you best content from here. And this is how our paid courses looks. This is how our paid courses looks. Basically, if you join our paid course, then our paid course are divided into 5 parts. What are these 5 parts? 5 parts basically. The first part, we will provide you theory content. complete theory lectures will be provided to you, right? In the second part, we will be also providing you study material, right? Once you are done with your theory, you have to study the theory. And the third thing is the live webinar with your personalized mentor, because we believe that every doubt is unique. And when every doubt is unique, you have to solve it uniquely. So once you are done with this live webinar, you will be getting homework, and these homeworks are checked. Regularly we are checking your homework so that we will ensure that you will able to crack the toughest exam, is JEE. Let's move forward. And here I have to derive one equation for you. I have to derive one equation. Side. On conductor. Okay, so electric field inside a non-conducting sphere. So we have to find out. Let's imagine that we are having a spherical shaped non-conducting spherical shape. Sir, obviously you are saying it's spherical. Sphere hoga. Huh? Are you seeing how perfectly I am drawing the spheres for you guys? Let's see. And here I am having center. Radius is r. And now if I'll provide some charge, charge will distribute. Charge will right inside the sphere, and assume that if we are taking radius r, inside the sphere, and at this point, at any point on this sphere which we are taking inside of radius r, we have to find out the electric field. Then what will happen? How many charges will be there, right? Because this is the Gaussian surface which we are considering. So basically, first of all, you have to identify that what is the enclosed charge here on this surface. So I'll be saying that if the volume of the sphere is 4 by 3 pi r cube, the charges are q, and if the volume is 4 by 3 pi small r cube, charges is, and this is what you have to identify, right? So I'll be saying that q dash will be divided by 4 by 3 pi r cube into 4 by 3 pi r cube, right? And you have to cross this 4 by 3 pi cut, and value of q is r cube so this is the value of enclosed charge. How many of the value? Please do let me know that how many of you understand. You become an IITian. तो भाई क्या समझ में आता? IITian बनना है हमें, आ गया। क्या भाई, तो देखो अब मैंने आपको कहा भाई चार्ज तो आ गया एनक्लोज चार्ज, एंड यू ऑलरेडी नो कि भाई चार्ज एनक्लोज अगर आपके पास आ गया है तो अकॉर्डिंग टू गॉसियन, अकॉर्डिंग टू गॉस लॉ, according to Gauss law we know that E dot ds का इंटीग्रेशन करना है हमें, सरफेस will be equals to q enclosed, q enclosed is this q dash only divided by epsilon naught, right? And this is the electric field which you have to find out. The integration of this surface is very simple, means just you have to write down the surface area of a sphere and you will easily get that what is the value here, and q dash will be q r cube divided by r cube epsilon naught, and this ds is 4 pi r square, right? This value is 4 pi r square. Why r square? Because this is the only area which we are taking, so this is 4 pi r square is equals to q r cube divided by r cube epsilon, right? So here we can cut this portion, this will cut, okay. So we will cut this portion and we will get that electric field is equals to r divided by 4 pi epsilon naught r cube. This is the value which we are getting, and this graph is also very important. Please note it down that if we will plot the graph of E to R, till here we will get this electric field is proportional to R. Please note it down. Electric field inside a Gaussian surface, electric field inside a Gaussian surface. Okay. Shall we move, my dear? This is what we are getting, right? So this is the enclosed charge. First we will find the enclosed charge. This is the derivation, but very important for your concepts clear. So this is done. Now I'll be asking you some question. I'll be asking you very good question. That we will decide whether this question is good or not. I'm saying that there are multiple charges on the axis. There are multiple charges on this axis. The first one is the 1 coulomb. Then at I'll be saying that this is center. Here there will be 1 coulomb, 0 coulomb. At 1 there will be 1 coulomb. At this point there will be 8. At this 3 point there will be 4 coulomb. Multiple charges are there. And similarly here as well. Okay. Let's consider this only. And if you are considering a Gaussian surface, you are considering a Gaussian of radius. आपने क्या करा, एक Gaussian surface ले लिया. So please do let me know. Please do let me know that what is the flux here. What is the flux here? And for your simplicity, I'll be taking it I'll be taking it 2.5 hours. Okay. Somebody is saying that sir, only these two charges are there. So the flux will be, total flux will be 3 divided by epsilon. Very good. Whoever got this answer is correct. Is absolutely correct. And now one announcement for you, that if you really want to crack JEE exam, you require personal attention, because believe me, without personal attention we won't be able to crack the JEE exam. If you are facing any issues, you can contact us. And here is what we are providing. We are providing a structured course. आपको इसके अलावा कुछ और चीज देखनी नहीं पड़े. We are providing you free study material, free test series, free question bank, free crash course access, assignment and DPP. So multiple things you are getting. Payment modes what are available here is all online. Well, also you can make the part payments. What is part payments, sir? Part payments, that means that you can pay in installments, as well as if you only want our structured course, you can buy that. If you only want crash course series from us, you can purchase that. If you only want study material from us, you can purchase that also. So this is what part payments means. So part payment means you can pay it through EMI, as well as you can pay it in parts. And currently an enormous discount is going on, that you can now access APJ Academy full year course for 1 month at rupees 490 only. So this is for the first time on YouTube. We are giving such an enormous discount. So don't wait and use this opportunity, 490, and get our course at rupees 490. The link is in the pin chat and also is in the description. So please get this fast. 4 seats got filled and you won't get admission. So till then, we will meet again with all of you in the next class. तो आज की क्लास को हम यहीं पर एंड करते हैं. Thank you everyone for joining. Bye bye.